Have you ever wondered how machines can learn like humans? It's a question that has captivated scientists and engineers for decades, leading to the development of one of the most transformative technologies in artificial intelligence machine learning. Just as we learn from experience, these algorithms can analyze vast amounts of data, identifying patterns and making predictions. From recommending your next favorite song to diagnosing diseases, machine learning is rapidly changing the world around us. In this video, we'll embark on a journey to explore the key concepts, types, and real-world applications of machine learning, unraveling the mysteries behind these intelligent systems. Imagine a machine that can learn from data without being explicitly programmed. That's the power of machine learning algorithms. These algorithms are like recipes, guiding the learning process. One type is the decision tree, which makes decisions based on a series of yes or no questions, much like a choose-your-own-adventure book. Then there are neural networks inspired by the human brain with interconnected nodes that process information. These networks excel at recognizing patterns and making complex decisions. Another powerful algorithm is the support vector machine, which finds the best boundary to separate different categories of data. From simple to complex, these algorithms are the engines that drive machine learning. Just as we need food to fuel our bodies, machine learning algorithms need data to learn. In supervised learning, the algorithm is fed labeled data, meaning each data point comes with a known outcome. Think of it like showing a child pictures of cats and dogs, labeling each one so they learn to distinguish them. This labeled data acts as a teacher, guiding the algorithm to understand the relationship between input features and the desired output. The quality and quantity of training data are crucial, as they directly impact the algorithm's ability to learn and make accurate predictions. Imagine you're trying to predict the price of a house. What factors would you consider? The size, location, number of bedrooms? These are all features that help describe the house. In machine learning, features are the measurable properties of the data that the algorithm uses to learn. Let's say we have a data set of houses with features like size, price, and location. The algorithm can analyze these features to understand how they relate to the price. For example, it might learn that larger houses tend to have higher prices. By identifying and understanding these features, we can train algorithms to make predictions about new, unseen data. After training on a massive amount of data, the machine learning algorithm produces a model. Think of the model as a set of rules or a mathematical formula that captures the patterns and relationships found in the data. It's like the final product of the learning process, a crystallization of the algorithm's newfound knowledge. This model can then be used to make predictions about new, unseen data. For example, a model trained on housing data can predict the price of a new house based on its features. The accuracy and reliability of the model depend on the quality of the training data and the effectiveness of the chosen algorithm. Training a machine learning model is like coaching an athlete. We provide the algorithm with training data and let it learn through trial and error. During training, the algorithm adjusts its internal parameters to minimize errors and improve its accuracy. It's an iterative process, repeating the cycle of analyzing data, making predictions, and adjusting parameters until the model performs well. The training process is crucial for shaping the model's behavior and ensuring it can generalize to new data. Just as a well-trained athlete can adapt to new challenges, a well-trained model can make accurate predictions on unseen data. Once our machine learning model is trained, it's time to put it to the test. Evaluation involves assessing how well the model performs on unseen data. It's like giving a student a final exam to see how much they've learned. We use various metrics to measure the model's accuracy, precision, and ability to generalize. A common technique is to split the data into training and testing sets. The model is trained on the training set and then evaluated on the unseen testing set. This helps us understand if the model has truly learned the underlying patterns or if it has simply memorized the training data. The true power of machine learning lies in its ability to make predictions about the future. Once we have a trained model, we can feed it new data and let it make informed predictions or decisions. Think of it like a weather forecasting model that uses current conditions to predict tomorrow's weather. Machine learning models can predict anything from customer behavior to stock prices, enabling us to make better decisions and optimize outcomes. The accuracy of these predictions depends on the quality of the model and the relevance of the input data. Supervised learning is like having a teacher guide the learning process. In this type of machine learning, the algorithm is given labeled data, where each data point has a known outcome. The algorithm learns to map input features to the desired output, much like a student learning from a textbook. Supervised learning is used for tasks like classification, where the goal is to assign data points to predefined categories, and regression, where the goal is to predict a continuous value. For example, a spam filter that classifies emails as spam or not spam is a classic example of supervised learning. Imagine exploring a vast, uncharted territory. That's the essence of unsupervised learning. In this type of machine learning, the algorithm is given unlabeled data and tasked with discovering hidden structures and patterns. It's like a detective piecing together clues without knowing the culprit in advance. Unsupervised learning is used for tasks like clustering, where the goal is to group similar data points together, and dimensionality reduction, where the goal is to simplify complex data by reducing the number of features. For example, a recommendation engine that groups customers with similar preferences is an example of unsupervised learning. Think of a child learning to ride a bike. They fall, they get up, they try again, gradually improving their skills through trial and error. That's the essence of reinforcement learning. In this type of machine learning, the algorithm learns by interacting with an environment and receiving rewards or penalties for its actions. It's like training a pet with treats and scolding. Reinforcement learning is used in robotics, game playing, and autonomous systems, where the algorithm learns to make optimal decisions in complex and dynamic environments. For example, a self-driving car that learns to navigate roads safely is an example of reinforcement learning. As we've seen, machine learning is a powerful tool that is transforming the world around us. From personalized recommendations to self-driving cars, these intelligent algorithms are revolutionizing industries and shaping our future. The possibilities are endless, and we've only just begun to scratch the surface of what machine learning can achieve. I encourage you to explore further, to delve deeper into the fascinating world of machine learning and discover how it is shaping various industries. Dive deeper into machine learning to unlock new possibilities.